Earth, the magnificent planet we now inhabit. Over time, this planet has inhabited different organisms and creatures, including humans, and it has served as a great home for all of us. In all of its grandeur, Earth does not disappoint when it comes to true beauty. In all of its stunning nature, however, there are still many questions unanswered. How was the Earth formed? Despite its beauty, why do catastrophes happen, such as earthquakes, volcanic eruptions, and tsunamis? Why doesn't the Earth just erode away? All of these questions can be answered in one simple process called plate tectonics. The idea of plate tectonics began all the way back in the 1600s. Little significance was given to this notion until 1915, when Alfred Wegener, a German meteorologist and geophysicist, wrote The Origin of Continents and Oceans. This book supports the hypothesis of what is called continental drift.
Alfred Wegener was a meteorologist who noticed, he had a sort of an interest in geology, and he noticed that there was a lot of information indicating that the continents were connected at one time. So he came up with this idea of a unified continent called Pangaea. So rock types, fossils, things like that. It was from the 1910s all the way into the 1960s. Relatively recently, plate tectonics came about, but we did not know the mechanism for plate tectonics, so that's why it was called continental drift.
The map shown here shows the continents and how they were separated, with what are called plate boundaries. There are three different types of plate boundaries. The first is divergent.
Well, the primary plate boundary that Wegener really didn't know about is a divergent boundary, and those make up the mid-ocean ridges. That's where convection comes up from the Earth's internal heat, and it actually pushes plates apart.
Divergent boundaries are the reason why our continents look like they do today. If you notice at the center of the seafloor, there is what is called a mid-Atlantic ridge. This ridge is the sign of a divergent boundary that ultimately separated North America and South America from Africa and Europe.
So that plate will actually interact with other plates, where you can have plates being shoved underneath other plates or converging, or even where they split and then they slide past each other.
This brings us to our last two plate boundaries, convergent and transformative boundaries. In a convergent boundary, the plates push into each other. In this example, it is oceanic crust converging into continental crust. Convergence, however, does not depend on what type of crust it is. It can be oceanic to oceanic, or continental to continental. The transformative boundary, the plates rub against each other or slide past each other.
So basically there's pull apart, come together, and then slide past.
Plate tectonics can, however, have some devastating effects. One of these being earthquakes.
What happens is where the plates interact with each other, I mentioned the pull, the push, the slide, that causes earthquake problems.
The day after the big Northern California earthquake, the San Francisco Bay Area. The digging out continues, and so does the counting of the dead.
NBC Nightly News with Tom Brokaw.
Good evening from San Francisco. This is the Marina District neighborhood. It was the hardest hit residential area in San Francisco. It is believed that between 3 and 5 people died in that apartment house right back there. Although I must tell you, most of the damage in San Francisco has been confined to this area, which is about 4 square miles altogether. I made a helicopter tour today of the entire Bay Area, and the greatest damage was right here on the Oakland Bay Bridge and, of course, on Interstate 880. Yet, more than 272 people are believed to have died. The death toll could go over 300 before we're all through.
Earthquakes, believe it or not, are not as bad as it gets.
You also have plate boundaries where you have extensive volcanism. When you have convergence, you actually have a thing called subduction, where some plates actually dive underneath. They partially melt and actually make magma that then drills up through the crust. So a convergent plate boundary can be a really nasty area where you get really high silica content produced, and that makes things like Mount St. Helens, Vesuvius, Krakatoa, the really damaging volcanism. Things like Hawaii, Iceland, you have places, basically Iceland, where the crust is being pulled apart and essentially the mantle leaks out. That sort of volcanism is much less intense. So those are two of the really bad things. One of the other side effects, or actually two of them, you have landslides because of over-steepening slopes. You also get tsunamis.
避難して山の方に上がって高台に上がっていく道路があるわけですね。そしてこれ津波が襲ったのはだいたい揺れてから何分後ぐらいですか。
When you have convergence, you actually have two continental pieces or two pieces of crust running together. That gets stressed, and you can actually have a section of seafloor pop up, and that just actually displaces the water above, which can be as much as 4 miles of water instantaneously. So that sends energy out at about 500 miles an hour in all directions. So basically the ocean surface lifts, shorelines in the vicinity drop, and then when that energy drops, the shorelines overextend. So basically the ocean is spilling onto land. That's a tsunami. So that's a really devastating thing. So the estimate is, the hypothesis is that we have continents in the Precambrian that were about the same size as the continents today. We can't go back then, but it's a hypothesis. So
Great. All right. Well, thank you.
welcome. Thank you.